Hello. In this video we're looking at MEI FP1, the May 2011 paper question 8, which is on complex numbers. Read the question through first. We're given a polynomial with real coefficients and told two of its roots, which are complex. We're asked to explain why p of z cannot be cubic. It's only 1 mark, so that's not going to be a long explanation. We're then told that it's quartic and asked to write down the other roots and then hence to find p of z, so using the other roots. We're then asked to show the roots of p of z on an Argand diagram and give in terms of z the equation of the circle they lie on. So we're told that they lie on a circle and we need to find the equation of that circle. Okay, so why is pz not a cubic? Well, if a polynomial has real coefficients, then its roots occur in complex conjugate pairs, complex roots. As we've already got two complex roots, there must be at least two more. Complex roots. So p of z must be order at least 4. So it is not cubic. Okay, writing down the other roots, just the conjugates of the ones that were given. So instead of 2 minus j, we get 2 plus j, and minus 1 minus 2j are the other roots. Now we can write down the factors. So we've got z minus 2 minus j, z minus 2 plus j. Make sure that your 2's don't look like z's. Z minus 1 plus 2j, and z minus 1 minus 2j. Taking out those inner brackets and making sure that we've got all the signs correct. Z minus 2 plus j, z minus 2 minus j, z plus 1 minus 2j, and z plus 1 plus 2j. Multiplying out, again we get z squared minus 2z minus jz minus 2z plus 4 plus 2j plus jz minus 2j minus j squared, and then z squared plus z plus 2jz plus z plus 1 plus 2j minus 2jz minus 2j minus 4j squared. Now when we simplify, we should lose all the j's, so minus jz plus jz plus 2j minus 2j, which leaves us with z squared minus 4z plus 4 plus 1, so that's plus 5, and then the plus 2jz minus 2jz plus 2j minus 2j, and we get z squared plus 2z plus 1 plus 4, so plus 5. Multiply those two together, z to the 4 plus 2z cubed plus 5z squared minus 4z cubed minus 8z squared minus 20z plus 5z squared plus 10z plus 25. And collecting terms gives us z to the 4 plus, no, minus 2z cubed minus 4z cubed, so minus 2z cubed plus 5z squared minus 8z squared, that's minus 3 plus 5, so plus 2z squared, and then minus 20z plus 10z, that's minus 10z, and plus 25. We've then got to mark these roots on an Argand diagram. So we've got 1 and 2 on our real axis, minus 1, minus 2, and then j and 2j on our imaginary axis, minus j, minus 2j. So we've then got 2 plus j, and symmetrically below the axis 2 minus j, and minus 1 plus 2j, and minus 1 minus 2j. Now we're told those lie on the circle, so all we need to do is to find the radius of the circle, which we can do by looking at one of the points. Let's take 2 plus j. So the modulus of 2 plus j is root 2 squared plus 1 squared, which is root 5. And so the equation of the circle is mod z equals root 5. And you can check that the other 3 roots also have modulus 5. Okay, let's see how the mark scheme works for this question. There is 1 mark for the explanation for part 1, which needs to mention that roots come in complex conjugate pairs. There's then 1 mark for each of the other 2 roots. There's a method mark for using the factor theorem to create the polynomial. There's a method mark for attempting to multiply out, and then there are 4 accuracy marks for getting the final answer, and it's minus 1 for each incorrect coefficient. And for the diagram, it's B1 for all correct with annotation on axes or labelled, and B1 for the equation. If you want to find videos of other questions on this unit or on other units, please visit the Further Mathematics Support Programme's website. Goodbye.